Alright, now that the robot arm is finished, let's get started working on the power supply. Now I was saying, the power supply is going to be a bit more complicated than your standard phone charger. So let's get into that now. So this is how the wiring is going to go. I'm going to have 3 wires coming into the power supply. The hot, or 120 volts, my neutral, or my 0 volts, and I'm going to have my ground, which is just going to be tied to the chassis of the power supply. Then, what I'm going to do is send the power through a transformer, and that's going to do a couple things. So, the first thing that this transformer is going to do is it's going to lower the voltage to a far safer 6 volts. The other thing that it's going to do is center tap that voltage, and let's get into what that means right now. If a transformer is center tapped, that basically means instead of 2 wires, there are 3. And the third wire, usually marked differently from the other 2, will be the wire that is connected to the center of the secondary winding, or the center tap. And it allows you to do some pretty cool things, like be able to turn a motor in both directions without the need for expensive motor controllers. Now, of course, for our purposes, this isn't right. It's not straight DC, and so it's not correct for what we want. So there's a few things that we still have to do. Now, before I continue on, I'm going to take a moment and, to make it easier to explain, I'm going to split this here off into 2 graphs. So, here's one right here, and we'll say that this is this side, and we'll say that this is this side. So in order to complete the power supply, the two things that we still need to add are a diode bridge and a capacitor bank. So, for the diode bridge, there's 2 ways that you can do it. You can do 2 individual diode bridges for each side of the transformer. But you can also do it across the whole 6 volts of the transformer. And the way you do that is the center tap just passes through the diode bridge, and then the 2 outside wires of the diode bridge just come down like so, and the diode bridge will just be a square like so, and the 2 AC wires get hooked to one side, and then DC wires come out the other side. Of course, in a bridge rectifier, all the diodes will point toward the positive side of the bridge rectifier. Now, the last thing that we need to add is the capacitor bank. So, that'll look a little bit like this. So, I kind of stumbled there, but basically, we'll just draw it down here for now. And so we'll just draw this down like so, and we'll just cross that out, and it'll come along like so, and our capacitors will go right here on the output of the bridge rectifier. So, with this capacitor added in, that's basically the whole circuit diagram complete. But how about component values? For most of the component values, it's pretty simple. For the diodes, it's just the current that you require, which in my case worked out to around 2 amps, so I went with 3 amps just to be on the safe side. And the voltage is 6 volts, so really anything above 6 volts will do. So I went with 3 amp 30 volt diodes. Now for the capacitors, it isn't as simple. To calculate the capacitance that you're going to need for this power supply to work, there's a formula, and it's 80,000 times the current you're going to want, divided by the voltage that you have. In this case, that worked out to around 26,000 microfarads, so I went a little bit higher. I went with 28,200 microfarads, or in this case, 6 times 47,000 microfarads. So now that we've found the capacitance, the last component value that we need to figure out is the voltage of the capacitors. In this case, we have 6 volts, so I went a little bit higher just to be on the safe side, and I went with 50 volts. And then that's basically the whole circuit diagram complete. With the addition of this diode bridge and these capacitors, we've gotten an output which is straight DC in both directions. So we'll have one graph that will have the center line here, and the voltage will be below center line, or negative, and we'll have another graph which again has center line, and the voltage will be above center line, or in this case positive 3 volts. With this being done, we're basically ready to get started building. So let's get to it. Alright, one more thing before we get started. Of course, credit where credit is due. This old Tony runs a cool channel by the same name. He made a very good video about power supplies and all the calculations and how they work. I'll leave a link in the description to that video, and that video was largely what I used to figure out what I needed to do to make my power supply work. So take a moment, go check out his video, and then come back here and we'll get started building. So what I have here is a 6-volt center tap transformer, and I have diodes and capacitors. Just a few things to note about wiring in this AC connector. When you're soldering the wires to it, you're most likely going to melt the plastic that's adjacent to the actual contacts. So what you do is you just put the connector into the socket, and then that way it maintains the pin spacing and so forth, so that you're not having your pins go all wonky on you and you can't get the plug back in. I will grant you, it is insanely sketchy. However, it should work, in theory. Technically speaking, this perforated board here isn't strictly necessary. It just makes it easier to maintain spacing on the capacitors. Now, word of the wise. These are electrolytic capacitors. Electrolytic capacitors are polarized, so it matters significantly how you hook it up. It has to be positive and negative. You can't flip the polarity. If you do, you'll end up with these blowing up. So just keep that in mind if you're ever using these. In this case, I'm not 100% sure that positive and negative on this bridge rectifier is right, but we're just gonna have to see. So, with everything assembled, I took it outside to make sure it was put together correctly. Now, what I had intended to do was, in addition to the manual controller, I wanted to use a controller that connected to a computer. However, due to the fact that I got 9 volts between the two legs of the capacitors, I was unable to use that controller board because the control ICs on the board weren't rated for that kind of voltage. Now, that said, let's try this. So if I go between here and neutral, ha! Look at that! 3.2 volts. And between there, 3.1. You know, we might be okay. I think we're okay. Yeah. Alright, sweet. And after doing a test with an equivalently sized motor to the ones used in the project, I think it's safe to say that this power supply should work very well in this project. And with that, I think I'm going to leave the video there. Just one more thing I wanted to mention before this video ends off. I did upload 2 videos this week, and I've left a link in the description to the other video I uploaded. Anyways, hope you guys enjoyed this video, and I'll see you in the next one.